Welcome back to the Quarterly Call. All content is for informational purposes and is not investment advice. Please consult with an investment professional. Hello, everyone, and welcome back. Today, we're digging into some really significant changes happening in computing. I'm here with our expert, and we're going to unpack some, pretty fascinating insights from NVIDIA's leader at a recent tech conference. We've reviewed the source material, looking at their vision for computing, AI, and robotics.
That's right. And our aim here is really to boil down a lot of information, pull out those key takeaways, to give you a clear sense of the big trends. Because these aren't just small technical updates. They could genuinely reshape industries, maybe even our everyday world.
Exactly. So what you'll hopefully get is a much clearer picture of these complex shifts, maybe some surprising details, and just a better handle on where this tech is actually heading. We sifted through quite a bit to get here.
Okay, so maybe let's start with the big picture shift they talked about. NVIDIA's own journey. Over 30 years, moving from, mostly a chip company to what they're now calling an essential infrastructure company. And that really started way back with CUD.
Okay, CUD. So unpack that for us a little. How does something like CUD turn a chip maker into, infrastructure?
Well, CUDA was the breakthrough because it let developers use the GPU's parallel power for general tasks, not just graphics. That opened the door. It made them realize that this new kind of computing, AI, needed more than just faster chips. It needed a whole new stack, a completely different data center design.
But how?
Instead of a few big processors, AI uses thousands working together. So you suddenly need incredibly fast connections between all those processors. It's a different architecture.
Right, the connections become critical. And that led to this idea of AI itself being a new infrastructure layer.
Exactly. That was a powerful comparison they made. Think about history. First, electricity powering industry, then information, the internet, the digital age. And now they're framing AI as the infrastructure of intelligence, built right on top of the other two. It really shows the scale they're thinking at.
Comparing it to electricity or the internet.
Yeah.
Yeah, that puts it in perspective. And then they talked about data centers becoming AI factories.
Yes, that's a core concept. They aren't just places to store stuff anymore. They're active factories. They consume power, sure, but they produce something valuable. Tokens.
Tokens, like
Yeah.
the basic building blocks of AI language and concepts.
Precisely. Words, parts of words, ideas. These AI factories are churning out intelligence in the form of these tokens.
Producing intelligence. That's a tangible way to think about it.
Yeah.
And the economic side of this, the numbers were huge, weren't they?
Oh, yeah. Trillions of dollars. That's the opportunity size they presented, which is, a big step up from previous estimates. It really signals they see this as a fundamental replatforming, not just another tech cycle.
Trillions. Okay. That number alone makes you sit up. So this new infrastructure, these AI factories, what's actually enabling them at the core? They emphasize software libraries, right?
Absolutely crucial. Beyond the silicon itself, the CUAX libraries are positioned as the engine. They accelerate all sorts of applications, but more than that, they actually create new markets. It's the specialized software that unlocks the hardware's potential in specific areas.
Can you give an example, something from the source that shows how these libraries really change the game?
Yeah, DLSS in graphics is a great one. Deep learning supersampling. Basically, AI guesses missing pixels. The GPU renders fewer pixels. AI fills in the gaps intelligently. Suddenly, you get super fast, realistic ray tracing that just wasn't practical before.
So it enables something entirely new.
Exactly. Or look at computational lithography making the masks for chip printing. That's incredibly complex.
Yeah.
Using their Calico library, they sped that up by like 50 to 70 times. And it's not just theory. Partners like TSMC, ASML Synopsys are actually using it. That's transforming how chips get made.
Wow, 50x faster on a fundamental step like that. Okay, so the libraries are key enablers. Now, shifting to AI itself, its capabilities seem to be evolving incredibly fast.
They really are. The source traced it nicely. A decade ago, it was mostly perception, recognizing images, understanding speech. Then, more recently, generative AI came along, creating text, images, code, acting almost like a universal translator between different types of information.
And what's next? Where are we headed now, according to them?
Two big frontiers were highlighted: agentic AI and physical AI.
Agentic AI. Tell me more.
It's fascinating. It's about AI that can reason, plan step by step, use tools, even collaborate with other AIs, like sophisticated digital assistants or digital employees was the term used.
Digital employees, that sounds transformative.
Yeah.
Was there a specific need driving this?
Yes, they explicitly linked it to the coming global labor shortage. They cited figures maybe 30 to 50 million people short by 2030. So agentic AI is seen as a way to augment human capabilities, fill that gap, handle complex digital tasks. Apparently, NVIDIA's own engineers are already using them for coding help.
Okay, agentic AI handles the digital side. What about physical AI?
That's for robots. For AI to work in the real world, it needs to understand physics, inertia, friction, cause and effect, that objects still exist when you can't see them. Object permanence. It's vital for robots navigating messy real-world spaces and also for creating those super realistic simulations needed to train them safely. Think synthetic data for self-driving cars.
Giving AI physical common sense. Got it. Now, all this needs immense computing power. Let's talk hardware. What are the latest systems mentioned?
The big one highlighted was Grace Blackwell, the GB300 platform. It's designed for extremely fast inference, that's the AI thinking part. And a key challenge they emphasized is scaling up, getting lots of processors within one system to work together super tightly. That's apparently much harder than just networking separate boxes.
And how are they solving that scale-up problem?
With NVLink, they called it the world's fastest switch. The bandwidth numbers are staggering, 130 terabytes per second across a rack.
Great.
Yeah, more than the peak traffic of the entire internet, just inside one rack of servers. It essentially connects all the GPUs so tightly that the whole rack acts like one massive distributed motherboard. And all that power density means liquid cooling is now standard.
An entire rack as one motherboard. That really paints a picture. The performance gains must be huge.
Astronomical. They said a single GB300 node matches the performance of the 2018 Sierra supercomputer, which used 18,000 GPUs.
Wait, 18,000 GPUs down to one node's worth in 6 years?
Yep. It shows the progress isn't just faster chips, it's the interconnects, the system design. And they talked about future AI factories like this proposed Stargate project, massive multi-billion-dollar facilities like industrial plants for computing.
Building compute like we build power plates. Wow. Is there any move towards making this more open or customizable, though?
There is. That's where NVLink Fusion comes in. It allows other companies to integrate their own chips, CPUs, custom ASICs into the NVIDIA ecosystem. They use NVLink chiplets and IP from NVIDIA to connect their silicon to the high-speed fabric. Partners like Qualcomm, Fujitsu were mentioned. It makes the platform more adaptable.
So you can bring your own specialized silicon into their world? That's interesting. What about smaller scale? Not everyone needs a multi-billion-dollar AI factory.
Right, they addressed that too. They showed the DGX Spark like a desk-side AI cloud. It packs the punch of a DGX-1 from 10 years ago into a tiny box for developers or researchers. And then there's the DGX Station, a personal system you can plug into a wall outlet, but it's powerful enough to run massive trillion-parameter models.
So scaling from your desk all the way up to industrial compute. Okay, what about regular companies? How does this AI fit into existing enterprise IT?
Yeah, that's a different challenge, right? Enterprises run on standard servers, hypervisors like VMware, existing software. You can't just rip and replace. The goal is to integrate these new AI capabilities, especially agentic AI, smoothly into that environment.
And what's the approach there?
They introduced a system called the RTX PRO Enterprise Server. It's designed specifically to run traditional workloads, virtual desktops, apps side by side with these new enterprise AI agents. It's built for compatibility with existing x86 systems and hypervisors.
Does it offer a significant performance boost for those AI tasks within the enterprise setup?
Apparently, yes. They showed comparisons like 1.7 times the performance of the previous H100 HGX on a model like Llama 70B and 4 times faster on DeepSeek R1. New tech, like their CX8 switch chip, helps with the internal networking. They did note that tuning for both high throughput and the low latency needed for interactive agents is tricky. Software is key there.
Specialized hardware for AI in the enterprise. Makes sense. What about data? AI needs data, and enterprise data is often locked up.
Exactly. And traditional storage isn't really set up for how AI needs to access information. AI needs to search unstructured data documents, emails, videos by meaning, not just keywords. Semantic search.
The storage needs to change too.
Fundamentally, the idea is that future enterprise storage won't just have CPUs. They'll need GPU compute nodes right there at the storage layer. Why? To handle the heavy lifting of making that unstructured data searchable by AI, things like creating embeddings, indexing them, running semantic queries. That's the concept behind their NVIDIA AI data platform and this AIQ query system. They're releasing open source models like Llama, Nematron, and Blueprints, working with storage partners.
So AI is pushing compute right into the storage itself.
Yeah.
That's a big shift. And managing all these AI agents, that must be complex.
Absolutely. If you have hundreds or thousands of these digital workers, IT needs new tools. That's where this idea of AI ops comes, and AI for IT operations. It's a new software layer to manage, monitor, secure, and fine-tune all these AI models and agents running in the company. They mentioned an ecosystem of partners already working on this.
Okay, compute, storage, management, a whole stack for enterprise AI. Now let's connect the digital and physical worlds, robotics and digital twins.
Right. This is where that physical AI becomes critical. You need realistic simulations to train robots, especially humanoids. Training only in the real world is just too slow, too expensive, too dangerous.
And they have specific tech for that simulation.
Yes, the Newton physics engine. GPU accelerated, handles complex physics simulations. Developed with partners like DeepMind, Disney Research, they plan to open source it and integrate it into platforms like Isaac Sim. It provides that virtual sandbox for robots to learn in.
And once the AI is trained there, how does it get onto the actual robot?
That's the Isaac GR00T platform. It bundles hardware like the Jetson Thor processor, which is designed for robots, with the Isaac OS runtime and foundation models. They recently open-sourced a version, N1.5, and said adoption is happening fast. It seems to be becoming a standard robotics platform.
How do they get enough training data for these complex robots, though? Simulation helps, but
Good question. A key technique is combining human demonstration with AI amplification. Call it reel-to-reel. Humans can guide robots through tasks, maybe via teleoperation. That gives the AI some initial examples. Then the AI uses simulation to generate massive amounts of synthetic data based on those examples, refining its skills through reinforcement learning. It takes a lot of compute.
right. And humanoid robots specifically seem to get a lot of focus.
They did, positioned as potentially the next multi-trillion-dollar industry.
Multi-trillion. Why such a huge number?
The logic is pretty compelling. Because they have a human-like form, they can potentially work in environments already built for humans, factories, warehouses, maybe even homes, without needing huge changes to the infrastructure. They're seen as a key way to tackle those labor shortages we talked about. But it's hard. It requires mastering AI learning, simulation, and robust deployment systems.
And how do digital twins fit into the robotics picture?
They're tightly linked. The source emphasized using digital twins, built in Omniverse, for training and deploying robots. If you want robots to work effectively in a factory, you need a super accurate, physics-aware digital replica of everything: the robots, the machines, the layout. They showed examples from companies like Delta, Foxconn, Pegatron, building detailed twins of entire factories.
So you simulate the whole operation digitally first.
Exactly. And this is really relevant now, with companies planning to spend something like $5 trillion globally on new factories in the next few years. Digital twins become essential for designing these factories, optimizing them, and managing them, especially as they fill up with robots. NVIDIA is even building digital twins of its own facilities.
So digital twins become the interface to manage this future of AI and robots. Interesting. Lastly, they touched on the local impact, particularly for Taiwan.
Yeah, highlighting Taiwan's central role in the whole computer ecosystem. These AI and robotics shifts are obviously going to have a massive impact right there, transforming local industries.
And NVIDIA's doubling down there.
Seems like it. They mentioned plans for a new, big office in Taiwan called NVIDIA Constellation, a sign of growth and commitment.
So pulling it all together, it's a really broad vision. For the basic infrastructure up to digital agents and physical robots, all tied together with simulation.
Yeah, they really framed it as this once-in-a-lifetime opportunity, not just building the next generation of IT, but essentially creating a whole new industry around AI factories turning out intelligence, AI agents working alongside us, robots handling physical tasks, maybe all orchestrated through these digital twins.
It's definitely a lot to process. The scale of ambition is huge. It makes you really stop and think about a future where AI agents are just normal colleagues, robots are common in workplaces, and massive factories are run through virtual replicas.
Well, and maybe a final thought to leave you with drawing from all this. Consider how deeply interconnected these pieces are. The AI factories provide the intelligence fuel. The agentic AI uses that fuel for digital tasks. The physical AI, trained in digital twins powered by that same fuel, enables robots. How might that complete ecosystem truly change the nature of productivity, manufacturing, maybe even creativity itself? It's not just one piece, it's the whole system coming together.
That's a great point. Definitely food for thought on how these shifts might ripple out and affect your own work or life down the line. Thank you so much for tuning into the Quarterly Call. For more episodes, please remember to rate and follow our show. Until next time, stay curious and stay informed.